Welcome to Unit 10. Today we introduce a brand new idea, and this idea is logarithms. Now, chances are you probably haven't heard of logarithms before. However, logarithms do have a really close relationship to something you have heard of before, and that is exponentials. So what we're going to do is introduce, or I guess review, exponentials first, kind of refresh your mind on them, and then apply those to logarithms so you can see where they come from and how they're used. So let's start by reviewing exponentials. So this is the basic exponential graph. I like to call it the hockey stick graph because it starts flat and then shoots up kind of like a hockey stick on its side. Exponentials are any number to a letter. So like 3 to the x, 5 to the x, 72 to the x, 2 to the x. Anything like that is an exponential, a number with a letter in the exponent. Now, be careful on these. X cubed and 3 to the x are totally different things. We are not talking about things like x cubed. We are doing exponentials 3 to the x. Those are totally different. So, you should have seen exponentials in the past kind of introduce what they are. Exponentials and logarithms have, as I said, a very special relationship in that exponentials and logarithms are inverses of each other. Now, we've talked about inverses before, but in case you forgot, an inverse means you flip the input and the output. Inverses are kind of like opposites, like multiplication and division. Those are inverse operations. Squaring and square rooting, those are inverses. They undo each other, they get rid of each other, they're opposites. And to find inverses, we always flip the input and the output, or flip the x and the y. So this is your graph of your logarithm, your basic logarithmic graph. You'll see it kind of looks similar to the exponential, except this time it looks like our hockey stick is standing up. So we've got hockey stick and then shoots off to the side. So that's your logarithmic graph, the basic one. Now when we talk about logarithms, the first key word that you need to know is base. And this word actually comes from exponentials. So if I look at this exponential right here, that 3 is called the base of the exponent. So that 5, that is the base of the exponent. And logarithms also have bases. So if I come over here to the log, but their base is written like a small number next to them. So for example, log base 3 of 2. Let's do 9 actually. Change my mind. So that 3 right there, that is called the base of the logarithm. And it does have a special relationship to exponential bases. We'll talk about that in a little bit. So we have base of the logarithm, base of the exponent. And just like exponents, this base could be anything. I could have log base 10, log base 81, log base 7. You can have anything for that base. But there are 2 bases that we do specifically want to talk about. And the first one is base 10. Now the reason we talk about base 10 is because it's extremely common. Base 10 comes up all the time. It happens all the time in mathematics. And because it's so common, we assume that any logarithm that doesn't have a base written there, we assume that it's a base 10. And that will hold true for every problem you do. If there's a base written there, like log base 3, that's a base 3. If there's no base, you always assume it's a base 10. That's kind of the most basic base there is. It's the one we use all the time. The other one we want to talk about is base E. Now, E is just a number, kind of like pi 3.14159265. It's a number that goes on and on and on forever and ever. And it came up so often that mathematicians gave it a name instead of actually writing out the number every time. Well, E is the same thing. E is a number that goes on forever and ever and ever and ever. And it actually turned up a lot in nature. So like biologists and those kinds of scientists who work with nature noticed that this number kept coming up over and over and over. And that number is 2.718281828, and it just goes on forever and ever and ever and ever. And so scientists were like, hey, this is a really long number. Let's give it a name so that we can call it something instead of just doing the number every single time. So they called this number E, just like pi. Now, we also talk about log base E. And because log base E kept coming up over and over and over again, we gave it a shortcut name. We called it ln, which stands for the natural log. Natural because it appears in nature all the time. So anytime you see this ln thing, that really just means log base E. They're the same exact thing. ln is just writing it in shorthand. It's a shortcut for it. So that is your basic idea, introduction to what a logarithm is. In the next video, we're going to talk about how to translate from logarithms to exponentials so that we can solve problems a lot easier.